All right. Hello, 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 everyone. Welcome to review number 4. You might notice that the camera might be looking a little bit different. It's usually up here, but that camera was acting a little bit cranky this morning, so I decided to just use my laptop camera. I figured this lesson would be a little bit shorter anyway, so how is everyone doing today? How are we feeling? Because it's the last stream for the month of July, because tomorrow is August, so I've been doing this for like 2 months now, which is pretty awesome. Yeah, school is coming on too fast. I start August 10th, I think, which is a Wednesday, so it's like a weird day to start. But man, summer was good. And then I got to start applying to college, which is not going to be fun. But it looks like everyone's doing good. So let's go ahead and get started with today's review lesson. Again, it's usually half an hour of our review lessons. I'm sure this will take even less than that. So yesterday we spoke about, we just built some projects really. So I come down here, we have Chohan, no, we built Chohan. What was it? Cows and Bulls, yes. We built Cows and Bulls and we built Pig Latin, a little translator right here, using some of the things we learned about working with strings. And then with Cows and Bulls, we work with, of course, our random library. And Luke actually had completed this beforehand, so we used his code to help guide us in terms of what we were doing. So shout out to Luke. Anyway, so I asked you guys yesterday what we wanted to do for today's review lesson, because really there's nothing to review. Like, we haven't done any concepts or anything, right? The point of the projects is to review. So you guys are down with just building a game today, just one more game. And then again, lesson 11, so next Saturday, we'll continue building. And eventually I feel like we'll get to the point where we'll keep learning, we'll start transition back into learning something new. So anyway, the game I wanted to build today is called Jungju. Now, this is a completely made-up name that I gave it. Luke informed me in the chat yesterday that he called it Mexican Standoff. So it seems like everyone has played this game before in some form. So basically, every player has a numbered card from 1 to 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in every round, each of the players puts down a card. Whoever has the higher value in terms of like card number, they win. And of course, it's going to be us versus a robot. We're going to code the functionality of an opponent player. So that's what we're going to do today. So let's go ahead and get started. Oops, let's come down here. And actually, let me ask, did anyone have the chance to take a look at this game? Anyone have the chance to sort of, build it or something, or, think about it, and share any of the ideas they had? All right, I didn't build it yet, but I thought a little bit about it since I played it before. Yeah, again, super simple. We'll be done with this in like 10 minutes. Anyway, let's go ahead and get started then. So, again, main thing, visualize. How are we going to set this up? How do we have everything work? So I'm going to go ahead and clear all my rules out. Actually, I'll just condense them into a little block right here. So I am sitting at a table. The robot is in front of me. We all have a deck of 12 cards, right? The robot makes the first move. Let's start with that. So the first thing we have is we have to have a deck of 12 cards, okay? So what I'm going to go ahead and do is I'm going to create 2 decks. I'll call it user deck, right? We'll make this an empty list for now. And we'll have a user deck, and we will have, robot deck. Okay. So those are empty decks right there. And I apologize, my lights just went out. So bring this down. So we have 2 decks here. And again, we need to have numbers from 1 to 12. Now, usually what we would do is we just copy and paste. Come on, programmers, we don't do stuff like that. Let's use a simple for loop to just put 12 cards in everyone's deck. So we'll say for I in range 1 to 13. Why am I doing 1 to 13? Because if I do an I for I in range, say 12, I would get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I wouldn't get that 12. And also 0 is not like a card value in the first place. So I have to have 1 there. And again, we're going up to, but not including. So that's why we get that 12, even though I'm putting 13 here. So if I print out this I, we should hope to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So these are all the cards I need. So I'll go ahead and say user deck dot append I, say robot deck dot append I, like that. This is just basically generating the decks for the users, for both the players at least. So if we come down here and then we print out user deck and we print out our robot deck, then we should hope to see 2 lists, right? And each list should contain 12 integers from 1 to 12. And that's what we got. So again, let's go back to our visualization. We've gotten our 12 cards. Now we need to figure out how everyone's going to start making moves, right? How are the turns going to work? Well, again, we're going to have to be working with a robot. That robot needs to be able to make its own choices. And the best way we can sort of simulate that, right, is through the random library. Import random. Okay? So we'll use the random library. And let's actually, how do I want to do this? Let's actually take this, and we're going to put this inside of a function. We're going to call this build decks. Okay? Now, you might be asking, why are we doing this? Well, I just want us to get used to seeing functions, because the point of functions is sort of to compartmentalize parts of your code into little snippets, right? So again, we're having a section of our code that builds decks, a section of our code that is making moves for the robot, and then we have our main sort of thing, the whole loop of the actual gameplay. So again, that's why we're using functions, just to organize our code, make it nicer to look at and stuff like that. So we're going to build our decks, right? And then we're going to return both of them. Now, I'm pretty sure this is something I haven't covered yet, but if you want to return multiple values, right, you see, usually we only return one thing, which is what we're used to, right? We're comfortable with that. But if we want to return more than one thing, then I could say return user deck, comma, robot deck. So these are the 2 things I want to return. I'll just separate them with a comma. And usually, right, let's say we have R as a random variable, and we want to save the output of our function, right? This returns 2 things, but I only have 1 variable here. What we can do is you can actually put a comma right here and put S, and so, or whatever you want to call it. And so this R will take the first return value, and this S will take the second return value. And again, we'll see that in action a little bit later. So now what we're going to do is, oh my gosh. No, okay. So let's go ahead and create our while true loop. Okay? That's where our main gameplay is going to be taking place. Let's open that up. Let me add a little bit more spacing there. So we have our decks, right? And actually, let me bring them out. So we'll say user deck robot deck equal to build decks. Oops. Because remember, this build decks function, right? It's returning 2 values. So this user deck variable will take my first return value, and my robot deck variable will take my second return value. Okay? So I have both decks now. Now we need to start making moves. So we'll say that my user play is equal to the input. What number would you like to use, right? What number would you like to use from your deck? Again, one thing what we need to make sure that we're doing is making sure that the input which the user gives us is clean, it's valid. If you remember yesterday when we were working with, what was it called? Cows and bulls, we checked to see that our user's input was a digit to make sure that it was the right length and stuff like that. So how should we do that here? Well, we know that our decks, right, are consistent of integers from 1 to 12. And we're asking the user to give us a number, so we can turn this into a int, right? We'll turn that into an int, and we'll say that if our user play is in our user deck, then we can keep going on. Otherwise, we can just print, oops. Otherwise, we'll say something like print that, or you don't have, oops, that card. My typing is little, fingers are weird. Anywho, so if our user play, right, whatever they want to put on the table, whatever they want to play, is in their deck, right, it exists, then we need our robot to then make a play. So we can come here, we can say robot play is equal to, we're going to use a random library, right, random dot choice. So what does random dot choice do? Well, given a sequence, random dot choice will just pull that item out. So we'll say random dot choice, and we'll give it the robot deck. How does this play out in English? The robot play is basically going to be a random choice from their deck. They're just going to pull a card randomly. This is getting a little ahead, but I was working a little bit ahead on solo learn and learned a little bit about try except statements. Could that be applicable here? Yeah, it definitely could. Let's move this down, and we'll explain try it again. Try and except is definitely, we'll talk about that later. But I don't mind answering this question because it's a good question. So the best place to try and accept would be useful here is on line 26, right? I'm wrapping whatever my input is into int function, right? Now, let me comment all this out actually, and I'll make a better example. So let's say we have this here, we print user play. I run this. Hello? Let me go ahead and reload the site. But it's a good question. So while REPL is taking its time, oh, there we go. Okay. So let me take this. And again, we're just going to go off topic for a little bit, and then I'll return to what we're doing, but this is worth answering. If I have this, right, it's just a normal input statement that I'm putting an int function around, and I want to print that out, right? If I put 3, it works. Run this again, but if I put 3 like this, I get a value error. You can't convert a string with words to an integer. So again, that's what I have here. How can I make this safer, better? Well, I can wrap this within a try and except. Okay. Except, and I'll break down the sort of syntax of this, but I'm sure you're familiar with it already. And let me just get it all filled out. Okay, perfect. So what are we asking Python to do here? Python, can you try taking my input and turning it into an integer and then printing that out? But if you get like a value error, right? If you get a value error, then just say that that operation doesn't work. What number do I want to use? If I put 3, this whole thing plays and that works out. But if I type in 3 like this throws up an error, throws up a value error specifically. So then it defaults to this statement. So that's how a try and except could be applicable primarily on lines 26. Good question. Let's go ahead and continue on. So Our robot makes a play from the deck. Our user makes a play. So now we have both numbers, right? Our user's number and our robot's number. Now all we have to do is compare the two. We could say that if our robot play is equal to our user play, then we know it's a tie, right? Because they're the same value. So print that is a tie. Now, let's say, right, else if my robot play ends up being greater than my user play, then I would say that my robot wins. Robot wins. Now, if it's not a tie and it's not my robot winning, then it has to be me winning, right? Player wins. So pretty straightforward, pretty simple. So our both of our players make their play. We get to see who wins. What happens to their card? Well, that gets put in sort of like the throwaway pile, right? We need to remove that from their deck. Now, this is an introduction to another method that strings have called dot remove. So again, they'll make their plays, right? We get to see who wins, who loses, whatnot. And then we take our cards and we put them in the discard pile, which in coding terms means we just remove it from our deck list. How do we do that? Well, all we have to do is say user deck dot remove. And again, what was my user's play? Put that there. We'll say robot deck dot remove, and we'll put not user play, robot play. And again, I know I haven't talked about using this before, so let me comment this, do a brief sort of overview of what dot remove does. Let me come down here. So we have the dot remove method, and it's literally what it reads as. You just remove something from a list. So again, let me go to my handy dandy students list. Okay, and let's say at some point in my code, I want to remove my name from this list, right? Again, let's print out students first. And then I'll say students dot remove. I'll type in my name, right? Because this name exists in this list. And now if I print out students, see when I first print it, I'm there. After I do the dot remove, I am no longer there. So that's the quick overview of what the dot remove function is and how we're using it to basically remove a card from a user's deck. So that's that. So again, let's go back to our visualization. And actually, before I continue, are we all okay with this? Are we feeling okay? This is pretty straightforward. So, okay, awesome. I just want to make sure I'm not getting too far ahead. So then we remove the cards, right? Wouldn't it also be kind of handy to sort of like keep track of their scores, like see who's winning? So what I'm going to go ahead and do is I'm actually going to come up here above my while loop and actually create user score is equal to 0. And we'll say robot score is equal to 0. Just so it's easier to look at. So if a robot wins, I want to add 1 to the robot score, right? Plus equals 1. And if my player wins, then I want to add 1 to my user score. Actually, I'll call this user instead of player so we don't get confused with how we're naming things. Consistency is key. Regardless, user score plus equals 1, right? And what we'll do is we'll come down here and we'll just print out a new line, right? We use our special characters. What do I want to print? Oh, yeah, robot score is robot score. Make that an F string, copy this. Oops. Get rid of this, right? Because I don't want that on the new line. Put a user score, and I'll put user score in here. Let's go ahead and actually try this out because we haven't really tried it at all. We've just been coding the whole thing. So I'm going to run this. What number would you like to use? Well, again, my deck is from 1 to 12, so I'll say 9. Hi. Okay. So now I don't have 9 in my deck anymore. So I'll say 10. I win. That's 1-0 in my favor. Say 11, 9. I already have that card. 6. So on and so forth. You get what I'm doing here. So yeah, that's basically it in terms of everything. The only thing that I think that we need to cover is how many rounds should this game go for? Like, what is the score that, who should get like the majority points? And I think I decided upon this earlier. It was like, if you have 5 points, that means you basically win the game because there's no way that someone can beat you with that or something like that. So we'll just go ahead and say if user score is equal to 5, right? That means they've won 5 times. Or if robot score is equal to 5, right? Either of these conditions could be true. We'll put these all in a big parentheses. Then we'll just break. And again, that break is used to take us out of this while true loop. So yeah, now let's play this and test it out. Let me open this up so you guys can see a little bit better. What number would I like to use? I'll say 12. We'll just start top down. 11. Oops, he won. 10, 9, 8, 7, 6, 5. Bingo. I won. I think you guys see that right down here. So yeah, there is our simple game of number compare. So how do we feel about that so far? Should I go over anything? Are we feeling confident? Yeah, all good? Perfect. I have a couple ideas for practice if you don't mind sitting here for a sec. I know you're trying to make those one. Dude, don't worry. If you got some ideas, let's go over it, man. It's just going to help us out. Let's hear them. Actually, while he does that, let's go ahead and actually save this. What should I call this? Mexican standard for Jungju. Jungju, just for consistency. Let's take this, copy that, paste it into there. So between, I think it was lesson 10 we started. First of all, when my friends and I played this in elementary school, we deal out random hands of 12 cards. What does that mean? I'm not sure what that, what do you mean random hands? So it doesn't necessarily have to be from like 1 to 12. You could have like 5, 6, 7, 8, like several times or something. So we'd randomly shuffle the deck instead of generating 1 through 12. Okay. Okay, yeah. Okay, I can see what we can do with that. Okay, yeah. I have an idea. So what we're going to do is, again, we have our game already saved. Let's come here to main.py and let's just restart. We'll just start again. And of course, I'll copy some code from down here because, again, there's no need for us to repeat ourselves. But let's go ahead and just get started with this. So I'm going to import random, as always. And we're going to have our build deck function. Now, what Luke is saying is we need to create a function that basically, I'm assuming, so do you have like so let's say you have like a big deck, right? Like a whole stack of cards, and it's 1 through 12 2 times. You have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 8, 7, 8, 8, 9, 9, 10, 10, 11, 11, 12, 12. and you shuffle that, and then you hand those out randomly. From a hand of 52 cards. Okay. Okay, let me think. Let me just look up. The decks could be varied about. Yeah. I get that. Standard 52 card deck. Let me just pull that up. So, what values did you guys give to your ace, and then all of your, like face cards? Like, was your ace just 1? Same as what we assigned, ace being 1, face being 11 through 14. Okay. So what we're going to do is we're just going to keep these in terms of numbers, then. I won't put like jack, queen, king, or whatever. 1 through 13. Yeah, okay. I see what you're saying now. Okay, we can do that. So let's come up here, and actually we're going to have what we call a big deck. Big deck. And this will be consistent. That's not what I meant to type. And we'll type, we'll have all of our cards in there. So we're going to create a for loop for I in range 1 to 14. Right? Because 1 is our ace. We're going up to, but not including that 13. So if I print this out, right? And we'll do build deck. You get 1 to 13. Perfect. Now, what we're going to do is we're basically just going to go for J in range 4. We're going to take our big deck, and we're going to append I to it. So what is this doing? This is generating each value card, and then underneath that, I'm going to add it to my deck 4 times, right? Because you have 4 aces, you have 4 2-value cards, 4 jacks, 4 queens, 4 kings. So we're generating all the values, and then we're adding it to our big deck 4 times. So if I print that out, big deck, and we use our build deck function, we get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11, 11, 11, 11, so on and so forth. So that is our whole deck, right? So we have all of our cards. Now let's go ahead and shuffle them. And I'm actually going to use this as an opportunity to introduce another function in our random library. It's literally just called shuffle. So random.shuffle, just like that. You give it big deck, and you'll see how this works once I print big deck after I shuffle it and before. This right here, and actually let me put like a new line so we don't get confused. So the top one is what my big deck list looks like first. And then after I shuffle it here, here's what it looks like. So again, you have 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. Now we're doing 9, 8, 1, 7, 4, 6, 8, 8, 1, 7, 5, 6. Just like that. And what we can do with this is we can basically take this big deck function, right? Because it has all of our cards in it, and we're playing with 2 players. So what we can go ahead and do is just cut this list in half and sort of, actually, no, wait. Luke, you gave 12 cards to each player, right? Or how many cards would you give out to each player if you had a standard deck of 52? I think when we played, we did 10, but honestly, it doesn't really matter. So, okay, yeah, let's just do that then. So again, my deck is 52 cards big, right? There's 52 elements in this list. And just to keep it simple, what we'll do is we'll just pull 10 from the first part of the list, and then we'll pull 10 from the end part of the list. Does that make sense? We're just going to take the first 10 elements from this list, and we'll say that's our user's deck. We'll take the last 10 elements from this list, and we'll say that's our robot's deck, right? So we'll use a little bit of sublisting here. So let me clear this out, or let me keep the shuffle at least. And we can say that our user deck is equal to our big deck. We're basically going to take the first 10 elements, and I'll say our robot deck is equal to, how do we do the last couple elements? We're going to go from -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So we're going to go from -10 to the end. Now if I print these out, right, user deck, robot deck, oops, invalid syntax. Oh, forgot to put the big deck. Okay. So our user deck is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. That checks out. My robot deck is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements as well. So again, we have our huge deck, we shuffle it up, and then we just take the first part, take the end part, and give them to either our user or our robot. It's just a lot simpler to do this than just create another for loop where you make a random dot choice from each list to pull them randomly. So are we all good with this build deck function? Because all I'm going to add now is just returning them. So I'm going to return our user deck. I'm going to return our robot deck. So how are we feeling with this, folks? Good. Yes, perfect. Awesome. Then at this point, everything is pretty straightforward, right? So I'm actually going to get rid of this, and we're going to come back to our old save, and we can literally just copy this. Because aside from changing up how our deck is built, everything else is pretty straightforward. Oops. Come down here. So build the deck, right? Give our user deck whatever our build deck returns. Give our robot deck whatever our robot deck returns. And I think what would be good is for us to print out our user's deck so they know what they can pick from. So, okay, let's go ahead and try this now. And actually, I'll say robot wins by putting down robot play, just so we can see that what he's putting down, what card he's playing. Okay, so let's go ahead and test this out now. I'll run this. It's going to add, name build decks is not defined. Oh, it's just called build deck. We'll call this build decks. What number would you like to use? Well, it's supposed to print out my deck, but say 10. Oh, no. I just realized what I have to do. We'll bring this here, and it's easier to see. Okay, so what number would I like to use? 13 is my highest, so I'll put 13 down. I win, so now I have, this is my deck of cards. I'll put 12, since that's my next highest value. I win again. Then I'll put 10. I lost. Robot put down a 12. Okay, I'll put down, next highest is definitely a 7. Robot put down an 11. I'll put 7 again. Robot put down an 8, so it's getting kind of close. Let me bring this out a little bit. All I have is a 6, so I'll just put 6. Robot's going to win. Yeah, Robot won. Robot had 2 13s, a 12, and an 11. That is amazing. So yeah, it looks like our robot got really lucky with how our decks got shuffled out. So how do we feel about that? Our decks are a little bit more randomized, a little bit more up in the air. We didn't think this game through in 4th grade. Hey, it makes a good programming exercise, so it's totally worth it then. But yeah, are we all good with what we've done so far with our advanced game of Junju? Yes, but hold up for errors. So you want me to, what do you mean by that? Because again, the only place where I think I'm getting a few, hold up. You might be getting some errors because of, we copied and pasted a whole chunk of code from another file. So that might be throwing an error right there. You should be able to just read the error message and it tells you what lines it's on. So if I say, for example, put build deck here again, I run this, it tells you what line the error gets thrown on, right? So line 17. So when I call this, it's not defined. So you have to realize that if you come back here, then putting S would fix your problem or rectify it. Type error, function object is not subscriptable. Are you using the same variable names as me? What line does it give you, though? Line 17. Oh, it's the same line. Okay. Type object, function object is not subscriptable. Function object, so that's definitely this, is not subscriptable. Subscriptable. Here, check your return statement here. Other than that, I'm really not sure what could be going wrong. Let me see if I can just copy paste the code into the chat. Maybe that'll work. You can use that. Oh wait, that's not the source. Oh. Then I'll wait then. I'm trying to think what subscriptable means. Oh, 12. Okay. Function object. So big deck. Do you have the wrong name here? Because big deck should be pointing to a list. Basically, what subscriptable means, now that I realize what line the error is on, is that you can't slice. You can't do slicing on it. So just make sure you're using the right variable name right here. Calling it big deck, I guess, or whatever you named it on your end. Misspelled. Yep. It can be like that sometimes. I'm pretty sure Python, or sorry, not Python, REPL has this thing called code intelligence, and I've always left it and disabled. But it sort of like tells you, I think, if you try it, reload the site or whatever, it'll tell you like what the variable names and stuff are. But I leave that disabled for now. Anyway, it looks like we're all good with this. So yeah, that is review number 4, our last July stream. I haven't set up the reoccurring classes yet for August. I'll be sure to do that. Sorry, Luke says, one more tiny idea. Sorry, go for it. What do we got? What do we got? But yeah, I haven't set up the reoccurring classes yet for the month of August, so I'll be sure to do that. And, you should see them within like a couple hours of us finishing up this stream. And again, next lesson, lesson 11, is still going to be not review, but project building. And I think after that, we'll start moving into our learning phase one more time. We'll start doing some other stuff. Could we maybe use a dictionary to store 1, 11, 12, 13 as ace, jack, queen, king? Yeah, you could do that. Let's see. Let's see. How do I want to do this? because okay, now I gotta think about this. Okay, so ace is 1, jack is 11, queen is 12, king is 13. So what we're going to do is we're going to make this from 2 to 10. Okay? And then what we're going to do is we're going to say for face value in ace, jack, oops, queen, king, or j in range 4, big deck dot append face value. And what I've gone ahead and done here is let me comment this out so we don't get any errors or whatnot thrown. Let's clear this. I hope this works. Print user deck, print, and we'll put our robot deck. I'll give you 1 second. I just want to make sure this is working just fine before I go ahead and explain it. Unexpected indent. Line 43. Oh, I forgot about all this. Anyway. Yeah, okay, so we've got all the values. And again, let me just make sure it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what have we done here? Because I know I just did a lot. So I made our original loop go from only 2 to 10, right? Because these are the only numbers where, the card actually has a physical number on it. Other than that, we have ace, jack, queen, king. So I created another loop that iterates over a tuple that has ace, jack, queen, king, and I add it to my big deck 4 times, which is pretty straightforward. So I'm going to assume that we're all good with that. So that's what we have so far. I'm going to go ahead and I'm going to remove this. Now what we're going to do, I'm going to come down here. And basically what we're going to do is we're going to create a function. We're going to say, I'm going to take this function and call it play to points. I'm going to take play. Okay. What this function is going to do is we're literally going to give it whatever our user plays or whatever our robot plays, right? Whatever they pick from this list, and we're just going to convert it to its point value. So if it's already 4, it'll just return 4. If it's something like queen, then it'll return 12. If it's ace, it'll return 1. If it's 8, like the number, it'll just return 8. So what we'll say is if play is in, I have this huge tuple here. And again, I'm using a tuple because this thing's not being, changed, right? It's just this. So if my play is any of these, then what we're going to do is we're going to also have a dictionary. We call it face value to points, right? So an ace is 1 point. A jack is 11. Oops, 11. A queen is 12. And a king is 13. Again, I'm going to just type it out, and then of course I'll go back and explain it. So then we'll say return face value to points. Put play in here. Otherwise, we'll just return play. Okay. I went over that really quickly. So let me add some spacing first, so it's just a little bit nicer to look at. Okay. So again, let me go over everything just one more time. So our build decks function, right? We need to have a deck that looks like this, right? 4 aces, 4 twos, 4 threes, 4 fours, 4 fives, 4 6, 4 7, so on and so forth. Now, originally I had created a for loop that iterates over 1 to 13, right? Now, what we want to do is instead of presenting our cards as numbers, we want to be able to put, K or Q or A in there, right? So it looks a little bit nicer. So that's only these 4 cards right here, right? These are the only ones where there's not a number. So to create a deck which has these numbers, I would just iterate over 2 to 10, right? That's 2 to 11. I'd add that 4 times. And I would basically get this block of cards already in my deck. Now I need to get my aces, my jacks, my queens, and my kings. To do that, I created a tuple which has ace, jacks, queen, king. I iterate over each of these letters, and I add it to my big deck 4 times. So then I'm able to get all of these. And that fills out my entire deck. And I just cut it up the same way we did before. So are we all good with our not our big dex function, our build dex function? Everything makes sense here. Yes, awesome. Okay. So now let's take a look at our next function, right? Play to points. Now, this play to points function is basically going to, hold up. There we go. Now it's done. Okay, sorry. So this play to points function is basically going to take whatever play our user or our robot makes, and then it's going to convert it into its associated point value. Now, the reason I have this dictionary is because the letter A, the letter J, the letter Q, the letter K, they don't have numerical values associated with them, right? So I have to make a dictionary that binds A to being 1 point, Jack to being 11, Queen to being 12, King to being 13, like that. And I'll say if any of the plays, right, because I'm going to give it this function, I'm going to pass in the argument of whatever my robot or my user chooses to play. I'm giving it that. And if their play is either ace, jack, queen, or king, then I'm going to return the associated point value of that play. So again, just some basic dictionary stuff we're doing there. And if we're returning that, right, that's only if it's either an ace, jack, queen, or king. Otherwise, we're just going to return the integer of the normal play, if that makes sense. So we're just going to return, like, if they give us 1, right, then we just straight up just return this. If they give us 2, then we're straight up just going to return this. So that's why we just default to this final return statement. It might be a little bit nicer to put else here, actually. So it makes a little bit more sense. And now the last thing, the last modification we're going to make is we're just going to get rid of this int function right here. Because again, that's going to be right here in our play. Okay. And what we're going to do now, one more change, we're going to put play to points. We're going to wrap our input in play to points. So whatever our user takes as input, it'll get converted into its associated point value and saved to our user play. And again, our robot play will be, actually, here's what I want to do. We're going to create a new variable. We'll call it user play points. And we'll say that is the play to points, right? We're going to convert the play to points of their user play. We're going to take their play, whatever they put down, we're going to turn it into its point value, and save it as user play points. And again, we're going to do the same thing with our robot play. We're going to give it our robots play. Now, all that we have to do is just compare or change these from play to points, because again, we have to compare the point values directly, not the play itself. And from their deck, I'll remove the play. So let me run this, and we'll take a look at how we feel. So I have Jack, 5, Ace, Jack, 8, 9, 10, 4, King, 10. We know that King has a value of 13, so it's the highest value. So if I play this, I should hopefully win or, tie. There's no way I could lose. So put King right there. The user wins. Perfect. Now we'll put a really low value to see if we can get our robot to put either a Jack or an Ace or something down. So put 5. Oh. Interesting. So it looks like my card is not being removed from this. I need to check to see. So user play is going to be a string, and my user play is going to be a string. Ah, okay. So what we're going to do now is we're going to go back, because user play is now going to be a string. We can't make it an integer. So now what we're going to do to fix that is we're basically going to turn all of our numbers, right, from strings to integers. No, from integers to strings. So I'll put str here. Again, I know it's getting a little dicey maybe. Let's just make sure it's working, and then I can go back and explain all the changes and whatnot. So I'm going to I'll put King again. Right, so I win that. I'll put 2 this time. Okay, it's getting removed from my list. The user 1, so I'm going to put down a bunch of low values, see if we can get the robot to put down like a high value. I'm just winning, dang. Okay, yeah, robot wins by putting down a Jack. So everything's working just fine. So now, let me put down an Ace. Let's finish this game up. Robot wins by putting down a K. I'll put down a 7. The robot, it was a tie. Okay, but I think everything's working. So now let's go back and touch upon everything. So we did this build dex function. We did this play to points function. I'll come back to this, why I made this str. Yikes, type error dict object is not callable. That's going to be somewhere right here. Again, probably just a spelling error or something. Let me try just copy pasting this code into chat. I don't think it's sent. I think the message was too long. I don't know. My chat might be broken again. But again, let me go over everything conceptually really quickly. So again, play to points, we're just binding our play to its associated point value, right? Pretty straightforward. Now, this is where it gets a little more interesting. My user deck consisted of strings, right? A, J, K, Q. And it also consisted of numbers, right? 1, 2, 3, 4. So it had strings and had integers in it. Now, what I did with this user play is I took the string input of what number my user wanted to use, right? You want to use an ace, you want to use a 2. Now, that was saved as a string. So when I went to remove it from my array, or check to see if it, or sorry, from my list, or check to see if it even existed. So let's say my deck had ace, 2, 5, and a jack, right? Ace, 2, 5, and a jack. We'll put that here. I'll put ace, 2, 5, and a jack, right? So we have strings and we have numbers or integers in here. Let's say I picked 2, right? I put 2 as my input. That would be saved as a string. Does the string 2 exist anywhere in my deck? No. Only the integer 2 exists anywhere in my deck. So could I remove the string 2 for my deck in the first place? No. So that's why what I did was I made all of my numbers strings. So I turned them all into strings. Why? Because it creates consistency, and also because it just makes my life easier. So that's what we did. There. So were you able to figure out the error? Just try copy pasting the entire error code into chat and I can take a look at it. Probably be easier as well. Ugh. Okay, I'm not seeing anything. So are we all good then in terms of what we've gone over? I'm feeling all right with that. Maybe my chat's broken. Yep, it was broken. I just had to open up another browser. I figured it out. I was using parentheses on the dictionary instead of brackets. Okay, good. Rip chat, yeah. I think so, but this was a bit complicated. Yeah, it was a bit complicated. We tied everything together, but that's what it is usually. You gotta, let's see. So I think we're okay. This review lesson, it's way more confusing to edit existing code than it is to start fresh. Yeah, that is for sure. So yeah, this review lesson, it was kind of long, but I'm glad we were able to cover. We went pretty thorough with this. I'm not gonna lie. So I'm glad we did that. I think we're done now. So we're happy with that. Again, thank you so much for a good month of. Sorry, man. You want to keep it short? Nah, it's all good, Doug. I don't mind. But we've gone ahead and we've covered basically everything I wanted to anyway. I'm just really frustrated with how chat just dies randomly. That's so irritating. But again, I'll create the reoccurring classes for the month of August. I should be doing the same thing Saturdays, Sundays, because school will be starting halfway through, so I'll be just fine. Yeah, I think we'll do maybe a couple more projects. I'll see what I have in my files. But I think that's it, really. I don't have anything else for you guys. I don't have anything to get started on early right now. So yeah, just take it easy, rest, watch videos if you need to just make sure you're okay with all the concepts we've covered. Go back over this one because I know this sort of code was a little confusing and it's really long as well. So yeah, guys, I will see you next Saturday, same time, hopefully, right? I'll just make sure that's all worked out. So yeah, stay safe, keep practicing, be well, and I will see you guys